I'm pleased to introduce our next speaker, Nic Jackson. Nic Jackson is a developer advocate working for Hashicorp and the author of Building Microservices in Go, a book which examines the best patterns and practices for building microservices with the Go programming language. Hashicorp provides open source tools and commercial products that enable developers, operators, and security professionals to provision, secure, run, and connect distributed application infrastructure. Hashicorp is based in San Francisco, and we're excited to hear from Nic. So Nic, take it away.
How is everyone? Come on. Just good? I'm super excited to be here. I'm like genuinely, I think, who loves DigitalOcean? 2 hands? Right. So what I want to talk about today is looking at collaborative infrastructure with Terraform. I had a pretty good introduction, but like, why has that guy got a picture of a crow? Right. So I'm an animal lover. And as well as much as I love tech, I love animals. I have 5 dogs, which is like probably 4 dogs too many. And this handsome fella here, Jon Snow, we rescued 2 summers ago. Why do I want to put that picture up there? Has anybody ever tried to train a crow how to fly? Right, it's hard. Terraforming infrastructure is not hard. It's easy. I've got a relatively long history with the cloud as well. I mean, I remember being introduced to Azure back in 2008, and things were a little bit different then. It kind of took a long time to spin up an instance, certainly not like the 5 seconds that you get these days. And I think it's important to look at why we've gone on that journey. Why are we here? Why are we looking at the cloud right now, right? And it's because of the way that we were developing software. So we started off monolithic, and then we realized there was a desire for bigger, more complicated systems. So we started to use things like platforms as a service. And that worked out really great. And then you start to sort of hit the edges of those platforms as a service. So you start to move to infrastructure as a service. Companies like DigitalOcean, you start pushing this stuff out and building your complicated systems and managing them more yourself. It gives you the flexibility. And this is where you start. Who's that? Who's done that? Everybody in this room must have deployed at least 1 droplet. And then did you add another one? And deploy 2 droplets. And then after you deployed your 2nd droplet, you kind of thought, well, I need a load balancer. So I'll add a load balancer. And then after you add your load balancer, you add a firewall. And then after your firewall, you add some DNS. And then after your DNS, you decide, hey, I'm going to add an API server. Then you add a checkout service. And then you add an email service. And then you add storage to that email service. And then another firewall. And you've got an awesome system, but you've got something which is complicated. There's a lot of time there to manually go through and configure and build that infrastructure, especially when it doesn't stop there. Because you start off in a single region and you deploy all of that stuff, but then you add another region, and then you say, hey, I need a dev environment, and then, well, I need a test environment, another test environment, another test environment, another test environment. And another. So what you kind of start to conclude is that, building multiple environments manually, it just doesn't scale. And not only does it not scale, but you can't get the reproducibility and the consistency that you need when you're building environments. which is where this comes in. So Terraform is a tool that's designed to give you that consistency. It's designed to give you the reproducibility. It's designed to allow you to codify your infrastructure so that your infrastructure code is almost self-documenting. And it's broken down into these three phases: write, plan, and apply. So write, well, this is all about creating that declarative infrastructure as code. You write the definition that deforms your infrastructure. It allows you to do things like storing this configuration in version control. That gives you history. It gives you the ability to collaborate. And if you can codify it, you can automate it. You get the reproducibility. If you've never used Terraform, and I'm going to look at a little bit more of a complicated side of a demo, but it looks like this. So it's not JSON, it's not YAML, it's HCL. What we think is somewhere in between the two. It's the happy medium between machine parsable and human readable. So you have a provider. A provider is the thing that kind of defines the top-level API. So it's the thing like DigitalOcean. It's where you configure your credentials and your access to your DigitalOcean account. And you can have variables. So in this instance, I've got a variable which is region. It doesn't have to be hard-coded. I can put these in environment variables, so I can create something which is dynamic. And then at the heart of all of the Terraform configuration, you have multiple resources. So this resource is defining a DigitalOcean droplet. I'm dynamically injecting the region, which is these funny squiggly var region, which is interpolation syntax. I set the image. I give it a name, and I can specify the size. And that's all there is to it. The next stage is that I run a Terraform plan. So the difference between like a plan and an apply is that you've got this extra step to be able to validate that you are going to make changes to your infrastructure that you intend to make. So a plan is going to tell you what are the consequences of the changes to the configuration that you've just written. How many resources are going to get created, how many are going to get updated, how many are going to be destroyed. They show you what is going to happen. And a plan is a single workflow. So you can include DigitalOcean, but you might be using your DNS with DN simple. You can configure all of that in your single Terraform configuration. And it understands the dependencies as well. So a Terraform plan understands that you need to create an instance, a droplet, before you can modify a firewall rule for that droplet. And the output from the plan looks something like this. So it's very simple. Again, it's a human-readable format. Apply takes that plan, and it uses the configuration, and it makes the changes to the infrastructure. It allows you to have that reproducibility. It allows you to provision multiple instances of your environment as many times as you like. Consistency. And it's pretty effortless as well. And like running one command, Terraform plan, Terraform apply, change all of the infrastructure. Easy-ish. And again, you have human-readable output from Terraform plan. It's going to tell you some of the results of its action. Computed values, those are things which are sort of being determined by the APIs, but ultimately it's telling me here that I've added one new instance, which is my droplet. I think when a lot of people sort of run into complexity with Terraform, it's around collaboration. Because you're on this journey. So you go from manually configuring everything. You go through clicking on the UI, manually installing software. And then you start to evolve. So you start to go to a semi-automated approach. You might have some bash scripts, maybe. Something like that. Again, it's giving you a little bit towards the reproducibility. But then as your infrastructure grows in complexity, as your application grows in complexity, you start to move to infrastructure as code. And from there, your team grows, and you need to start thinking about, how do I collaborate on infrastructure? One of the ways I think that you collaborate on infrastructure is that you leverage the same techniques that you use if you're writing application code. So how do you collaborate on application code? A lot of people will use a GitFlow model. You make changes in a branch. You validate those changes, and then you merge them back down through your environments. So in this example, I could have 3 branches. I have a branch which defines my development environment, a branch which defines my staging environment, and a branch for my production environment. I can migrate the changes through my environments step by step, which gives me the absolute security and safety and confidence that what ends up in production is tested. And because I'm defining things as infrastructure as code, I can be sure and safe that the intended change that was made in dev is going to be the same change that is applied in production. With Terraform out of the box, Terraform uses a state file. And a state file is really important because a state file is what controls what is existing. So it's the plan is the diff, it's what will be. The state is what is now. And if you're running Terraform on your local machine, that state file will be sitting on your disk. And that's not going to work well with collaboration because you want your state file to be shareable amongst your team. And to enable that, what you have is a capability called remote state. So you can automatically have your state stored in a backend, such as spaces. And every time you run Terraform plan, Terraform apply, Terraform's going to use that as a source. It's not looking at your local machine. And this becomes even more important when we're running on CI. Remote state configuration, quite straightforward. Because DigitalOcean spaces are S3 API compatible, we can just use the S3 backend for Terraform. We don't need to have a specific backend for a DigitalOcean spaces, which I think is incredible. A few very basic parameters and configuration elements, but that's pretty much all there is to it. But then there is another problem, because you have one state per environment. So your dev environment has a state file. Your staging environment has a state file. Your production environment has a state file. So how do you manage that with Terraform? To be able to leverage that branch-based workflow, we can introduce yet another Terraform feature, which is workspaces. And what workspaces allow us to do is to be able to migrate through those various different state files as we change branch. It gives us the capability that we don't have to have separate configuration files. We don't have to have anything overly complicated. We can just use a simple command, Terraform workspace, select Terraform workspace new, to be able to manage those different environments. And on the GitFlow, because now we've got our workspaces, we've got our remote state, we've got everything set up and configured, we can literally just take an approach that you would take with your application code. You make a change in a branch, you commit it, and you open a pull request. Somebody's going to look at your pull request, you go through a code review exactly the same way as you would do with application code, approve it. If you're integrated with CI, you can actually get the checks which are coming back from your CI system. So even before you've merged a pull request, you can see that the plan has been successful. You can see that the changes to the configuration are valid and are applicable. And again, using something like Circle, one of the things that I really like about Circle CI is that you've got this hold step. So Circle CI allows me to build workflow-driven CI jobs. So I have a job, which is my plan. And then I have a hold job, which is a very specific kind of job which requires manual intervention. And then I have an apply. So why do I want this hold job? Well, I want the hold job because if I'm changing my production infrastructure, I want to take that extra step of safety. I just want to be 100%. And you may choose to only configure this so that your production branch is manual intervention. You may decide that, you know what, hey, if the plan works, I'm going to run it automatically with dev and staging. But that's configurable. That's based on your team's workflow. Well, you kind of can't see that, but you can trust me that what you're going to get as well is the same output that you had from the Terraform command line. You're going to see that in your CI system. So you've got that archive. So a lot of the time, the jobs are available after the fact in your CI system. So running Terraform will give you that ability to go back in time and have a look if need be. Same thing with the apply, exactly the same output that you're going to get in your command line. So I wonder if I can get this to work. Let's take a look at a little bit more of a complicated configuration. So what I've done is I've broken up my config into separate files. So Terraform doesn't need separate files. You could just put everything in a single file. But it's kind of good to break things up in terms of function. So what I've done is I've broken things down. Let's start with my main file, which is my terraform.tf. So I'm defining my provider, DigitalOcean. I don't have any of my user credentials in there. I haven't got my DigitalOcean API token because I'm injecting that as an environment variable. So I could either hard code it inside of the provider block, which is bad because then you commit it to GitHub and then it leaks and then you find out you're helping somebody mine Bitcoins on your DigitalOcean credits. So you take an element of security with that. Environment variables, 12-factor, it's a pretty good place. I'm not going to show you the environment variable because I've made that mistake before. But then I'm defining my backend. So it's exactly the same as the example I showed you. I'm using S3. Like, not DigitalOcean, but S3. Same API, works perfectly. I specify the bucket that I want to put my state into, and then I can specify the key. Region actually doesn't really need to be set, but it's just a quirk of the way that the provider works, that it will complain if you don't put a region in, so I just put any old stuff in there. And then again, my endpoint, which is from my DigitalOcean spaces. So when you look at that inside of DigitalOcean and you see your spaces, it's just going to be stored in your env, and you're going to see a folder per environment. So I've got a dev, master, and staging. And again, inside there, my Terraform state file, which I'm not going to show you because there's one important thing that you need to know about Terraform state files. They can contain secrets. So you've got to be very, very careful with them. Why do they need secrets? They need it because Terraform has to understand the diff. And quite often that involves understanding the diff of secret data as well as publicly available. So again, I'm not having people Bitcoin mining on my account. Not today, anyway. So what I'm doing is defining variables. So I've got a variable which is an instance count, and I've got a variable which is the region. The instance itself is a DigitalOcean droplet. So I'm utilizing the variables that I created in the previous file here. So I'm using this interpolation syntax. So $curly bracket var instance count. When the plan runs, Terraform's going to substitute that for me. It allows me to build that dynamic configuration. Setting the region, I'm just hard coding an image, and then I'm setting the name. So count is a special type for Terraform. It means that I want you to repeat this resource n number of times, where n is the value assigned to count. And I can utilize that variable to build up unique names and also to be able to select my volume, because I'm mounting a volume onto this instance. Network. So I've called this network, but this is going to contain my load balancer and my firewall rules. I put this into a separate file as well. So I'm specifying Terraform workspace to create a unique name for the load balancer. Again, that's going to relate to whatever my workspace is, like dev, staging, master, production. Using that variable for the region, and then I can set the forwarding rules. I can add multiple of these forwarding rules. I'm just adding something simple here, specify my health check, and the droplet IDs that I want this applied to. Very much the same with the firewall. So my resource for my firewall, I can specify my inbound rules. I don't have any outbound rules, but I can add those in there as well. All of the capabilities that you can do from the DigitalOcean API or that you can drive through the UI, you can define as infrastructure code using Terraform. And running it, this is the bit I don't like. So I run Terraform plan. That's my first step. So Terraform is going to contact the remote state bucket in DigitalOcean Spaces, and it's going to check my configuration against the known state. And correctly, it's telling me no changes, because I haven't made any change to the configuration. So let's increase the number of instances. So instead of one droplet for my web, let's create two. And I'm going to run Terraform plan again. So again, connecting up to spaces, pulling down the remote state, nothing on my local machine. And it's going to analyze the configuration. It's going to look at that. It's going to say there is one existing droplet in the system. And it's going to tell me that I need to make 3 changes because I'm updating my firewall rules. And I'm going to add 2 new resources. I'm adding my new data disk, and I'm adding my new droplet. And just wait for that to refresh. You'll see these are the existing droplets that are in the account. So let's apply that. Just 1 second. Okay, so now what I'm getting is that confirmation. Am I absolutely certain I want to make these changes? I'm as certain as I can ever be. So I'm going to say yes. So what Terraform's doing now is Terraform is using the DigitalOcean API, and it's creating those droplets. It's creating the droplets. It's modifying those firewall rules. If I refresh over here, you can see that I've now got a new droplet, which is coming up, droplet 1, so 0 indexed. And that'll take, like, what, a whole 25 seconds or so to create, but Terraform will just sit away in the background there, and it will just make those changes, eventually applying them and creating me the infrastructure as I need. Completely reproducible. I can run it on another environment. Like, if I can do it, anybody can do it. I have a whole 12 seconds. So if you want to have a look at the example code, I do have a little repository there. You can kind of find how to use the remote state, and just a simple example on how Terraform can be used with DigitalOcean. You can reach me at Twitter or by email. I'm more than happy to help anybody, and thank you so much for listening, and get terraforming. Thank you.